Hi, welcome back. This lesson today is about area of composite figures using partial circles. Let's go ahead and get started. So you have a formula sheet, and let's remember how to find area of a circle. Area of a circle is only one formula. Let's go ahead and get a pen so we can start writing. Okay, so area of a circle is pi r squared. Okay, so area is pi r squared. In this case, they gave us the diameter. We can't use that. Our formula doesn't ask for diameter. So the radius is going to be determined by dividing the diameter in half. So in this case, it's going to be 4 centimeters. Okay, given this information, we're going to do 3.14 and we're going to do 4 squared. So 3.14 times 16. Now with your calculator, go ahead and calculate this value to figure out what the area of this total circle will be. And in this case, we'll find that it is 50.24 centimeters. And because it's area, remember we always square our units. So there we go. Make sure you have that information, the image drawn with the work in your notebook. Excellent. Well, what if we needed to find the area of a partial circle? So in this case, we have a semicircle. Again, the formula is area equals pi r squared, but since it's half of a circle, we're going to divide that by 2 now. All right, so 3.14, and they already told us what the radius is, which is 12. We're going to square that, and then we're going to divide the whole thing in half. So 3.14 times 144, and then we're going to divide it by 2. Okay, go ahead and calculate this into your calculator. And when you do so, you're going to find that your value for the area of the half circle is 226.08, and it is millimeters, very small, squared. That would be your final answer. Make sure you have the image and the work shown on how to find the area of a semicircle. Well, again, a composite figure is a combination of several regular figures put together. And we need to find the area of this irregular shape. Okay, so here we have area 1, here we have area 2, and area 3. All right, well, the easiest one is area 2, and area 2 is going to be length times width, and so it's going to be 10 times 8, or 80. Over here for area 1, it's pi r squared divided by 2, and the diameter is 8, so the radius must be 4. So it's 3.14 times 4 squared, which is 16. We're going to divide the whole thing by 2. And when we do that, you'll find that the value will be 25.12. So I'm going to write that over here, 25.12. And then I have this area of the triangle. So area 3 is area of a triangle, which is 1/2 base times height, or we talked about base times height divided by 2 is an alternative way to write it. Seems to make more sense. The base is the dotted line, which is 8. So we have 8, and the height is the distance between the base of our triangle and the very top part. And it's not given to us within the triangle, but they showed it to us out here, and that value is 6. And we're going to divide that by 2. So 48 divided by 2 is 24. So the area of this part is 24. Now we have to add all three together. So we have 25.12 plus 80 plus 24. We're going to add them all together. So the area of the whole composite figure is plus 24 plus 80 is 129.12, and we don't know what it was, so we're just going to say units squared. Very good. Make sure you have everything in your math notebook. All right, well, let's go ahead and find the total area for this shape. Now I'm going to go ahead and draw a line across here. Boop, 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 boop. Going straight across. Okay? So we're going to have to do some calculations. So we have a rectangle, which is area 1, and then we have a semicircle, which is area 2. So for area 1, we know that this is 7 and this is 2. So 7 times 2 is 14, and it's centimeters. Well, now let's do our area 2, our circle, our half circle. So if the whole thing from here, from this edge to this edge is 7, then the same would be true if we went up on top of this rectangle. So that should be 7. But instead they gave us a 2 and they gave us a 1. So the diameter is going to be 7 minus the 2 plus 1, which is 3, so it's 4. So our diameter is now equal to 4. And if that's true, if the diameter is equal to 4, therefore the radius is equal to 2. All right, well, let's find out what that part is. Area equals pi r squared. So it's 3.14 times the radius, which is 4, and it's squared. And we're going to divide it in half because it's a semicircle. So 3.14 times 16 equals, divided by 2 equals 2512. So the area up here is 25.12. 2512. And if we add the 2512 plus the 14 that we already had from below, we're going to get our final total area is 39.12, and this is centimeters squared. So that little squirrel is a little happy tonight. Very good. All right, next one. All right. Now, in this situation, we want to find the area of the shaded region. So we're given a rectangle. So this one is given quite a bit of information that we're going to have to reason through. Basically, our line, if we went from this end all the way across to this end, that would be our length, right? And then from here to here is our height. So area is going to be length times height, or length times width. Well, here we go. If this line is 3, that's a radius. That would mean the diameter here would be 6, and then we would continue and we would have another radius which would be equal to 3. So 3 plus 6 plus 3 is a total space of 12. Now, to go from top to bottom, you're going to have a radius going one direction and a radius going the other direction. We already determined that the radius is 3, so therefore the distance from top to bottom is 6. So we're going to have 12 times 6, and we know by knowing our multiplication facts that that is 72. But that's the area of the entire rectangle. What we need to do now is figure out the area of the circle and subtract the different circle parts. So for area 2, it's area of a circle. We know the area of a circle is pi r squared. And we are given one entire circle, and we have half of a circle over here and half of a circle over here. And if we were to combine the two of them, we would have two circles in our shape. So let's go ahead and figure out what area of one circle is. So 3.14 times our radius, which is 3, and we want to square it. So 3.14 times 9, and let's see what we get. we're going to get 2826. So the area for this area region is 28.26. Well, if I cut the 28.26 in half, I would get this region over here that's half of a circle. And then I have another region over here that's half of a circle. So really, that's a whole nother circle. So the broken up parts, we're going to call this area 3 and area 4. If we add area 3 plus area 4, we would see that we would get the same thing, 28.26. So if I add that one with my old one, 28.26, if I added those together, I would get a total of 56.52 units squared. And now we want to subtract. We want to take the 72 and we want to take out the circular parts. Well, that is 56.52. And you're going to find that the leftover value is 15.48. And we don't know our units, so we're just going to say units squared. Okay, make sure you understand this or write down the questions you have, but copy all the information down. Excellent. Now, what if we wanted to paint a wall and in the wall there were two windows? Well, we wouldn't want to paint the windows, so we would need to figure out what is the area of the shaded region. So we know that this is going to be a square because of the hatch marks. This says there's 3 and 3, so 12 times 12. So the area of the large version, we have 3 regions. The area of the large one is length times width, which is 12 squared, so it's 144. And we need area of 2. An area of 2 has different hatch marks, and it says that it's 6 squared, so that's 36. And we have area of our third one, and that's going to be 3 squared because it only has one hatch mark, so it's 3 squared, which is 9. So we're going to add our two non-window, we're going to add our two window parts, the non-shaded. Okay, so 36 plus 9, and we're going to get 45. And we want to subtract that from our 144. So we want to say 144 would be the entire wall, but we want to take away the 45 that is not going to be shaded. And so we're going to do that, and we're going to end up with having 99, and I'm just going to go ahead and call it feet, although we don't know, feet squared. Very good. Copy that all into your notebook. Okay, we have one final example. Here we have a rectangle and we have a triangle. So we're going to find the whole shape of the larger shape first and then take out the secondary shape. So this is area 1 and this is area 2. So for area 1, we know that it's length times width, which is 10 times 8. So that's 80. And area 2 now is base times height divided by 2. Well, our base in this case is 7 based off of the measurement that they told us. Our height would be from our base up to the top, and we can see that this height is also congruent and parallel to all of the edges of our rectangle. So we're going to say that the height is the same thing, which is 8. We're going to divide it by 2. Okay, so using your calculations, you're going to figure out the value, and we're going to say that it's 28 units squared. And now we're going to subtract them. So we're going to take 80 minus the 28, and what are we going to find? We're going to find that the region of the wall, or whatever we're going to call it, is 52 units squared. Starting with the hole and taking out the one window. Okay, make sure you have all this copied down. For the Your Turn page today, what I'd like for you to do is find the area of the images of your flipbook. I want you to do examples 1 through 4 in your flipbook, and this time I want you to find the area. Last time we found perimeter, now you're going to find the area, and you're going to write this on the lined section of your notebook. All right? Good luck, and I will talk to you all tomorrow. We'll go over these answers and ask any last minute questions you might have.